Algebra 1 students, welcome to your 2.2 notes, solving two-step equations. The process is very similar to what we did in 2.1 in class today. We will, of course, go an extra step, as the name would imply. A reminder to begin with, inverse operations are operations that undo each other. We saw this in our 2.1 notes where addition and subtraction undo each other. So we could put those two there. And then, of course, multiplication and division undo each other in the same way. Now the question becomes, well, again, why do we need this? And just like what we saw on 2.1, it's so that we can get x by itself when solving equations. So let's take a look at an example. Number 1 here, 3x plus 5 equals 20. First, we would subtract 5 from each side. So minus 5, and that's going to give us, it's going to isolate the 3x, and we'll have 3x equal to 15. Next, trying to get x by itself, we have to use our division property of equality. So we would divide both sides by 3. And finally, we'd know then that x is equal to 5. So let's take a look at this second example. Again, our goal, as we've seen, is to get x by itself. We'll start by adding 2 to each side. Now, some of you may be saying, Mr. Hale, wait a minute, I thought when we did order of operations that you would do division or multiplication before you do addition and subtraction. And that's true, but remember, since we're basically unwrapping these equations, you have to go in the opposite order for the order of operations. So everything just gets switched around. All right, so here we go. X over 4 equals 10. We can multiply both sides of this equation by 4. That will knock out the 4's over here, just leave us with an x equal to 10 times 4, which is 40. Onward. All right, let's do number 3 together as well. So in number 3, we have a negative x plus 6 equals 9. Again, our job is to isolate x. So I'm going to subtract 6 from each side, and I'll have negative x equal to 3. Now, one thing you might want to consider when you see negative x, I'm going to change the way I write that here just so we understand what we're doing. It's actually a negative 1x. And the reason I think of it as negative 1 is because then I know I need to divide both sides of the equation by negative 1, and I would have x equal to negative 3. All right, let's look at number 4. Now, in this case, because of a grouping symbol, this big fraction bar, I'm actually going to have to deal with multiplication before I address the addition and subtraction. So we still are considering that order of operations, but those grouping symbols are changing the order that we're going to attack this one. So we're going to multiply both sides by 3. And so 3 times x plus 5 over 3 just gets rid of those 3's, leaves us with an x plus 5. 10 times 3 is 30. And now we're into the familiar one-step territory. Just subtract 5 from each side, and x would be equal to 25. All right, so a little different approach on that one. That grouping symbol would normally mean you would have to do x plus 5 before you divide by 3, but since we're unwrapping it, we have to work opposite order. Kind of a little tricky little thing if you're not careful. All right, let's do some application problems. Susie has $26 and a coupon for $2 off. A CD is $3. How many CDs can she buy? Right there, folks, that little phrase, how many CDs, tells you what your variable is going to be. I'm just going to use X. You can use any letter that you'd like, but I'm going to say X represents number of CDs. And folks, I know it's sometimes tempting to skip labeling the variable. We will not do that. We will always label a variable when we have an application problem. so that we know what we're looking for and we know what it represents in the context of the equation that we write. So it says CDs cost $26, or excuse me, $3. They're apparently on sale, cheapies, $3 per CD. Fun, fun. 3 times the number of CDs, and she has a coupon for $2 off. So we can do 3 times the number of CDs minus 2 is equal to, and then this is the amount of money she has left. So again, I'm taking $3 times the number of CDs. I'm subtracting $2 because of her coupon. That's giving her a discount. And it has to equal 26. So let's start unwrapping this equation. We'll add 2 to each side. And we'll have 3x equal to 28. I'm going to rewrite that over here. And then we can divide both sides of the equation by 3. Now this would give us 9 1/3. Now the issue is a third of a CD is not very useful. They don't work actually. So what we would say is that Susie could buy 9 CDs. Quite the deal. 9 CDs, $26. All right, here we go. Frank is going bowling. Shoe rentals, $3, and each game is $2.50. Frank has $12. How many games can he bowl? Right there, that question is telling you the variable again. So again, I'll stick with the variable x. It's a simple one to use, and it represents the number of games that he's going to bowl. And we have to then look at the variable. We have to look at this scenario, and we know shoe rental is $3, so he's going to have to pay that regardless. Plus, he's going to pay $2.50 per number of games, and at most he can spend $12. So now our job is to go ahead and solve this equation for x. Let's start by subtracting 3 from each side. So we're going to have 2.50x, and note that I left out the 0. It's not necessary. It's okay if you have it, but it's not needed. 2.5x equals 9. We need to divide both sides by 2.5. Now this is kind of a weird scenario to take an integer value and divide by a decimal. And it actually might be easier, since we're doing this by hand, to do it as a fraction. But here's what I know. This is 3 times 2.5 is 7.5. 4 would be 10. So it's in between 3 and 4. And it leaves us a strange remainder of 1.5 over 2.5. Now we don't really like writing numbers that way. We would prefer something like 3 3/5, or maybe 3.6. But in any case, that whole remainder situation isn't very important, because it's not enough to pay for another game. He doesn't have a full game. He has 3/5 of a game left, and they're not going to let him bowl 6 frames and stop from there. So what we would say then is that Frank can bowl 3 games. All right, last topic we're going to look at today is it's still two-step equations, but we're actually going to put some reasoning behind every step. Now this is a little bit different way of doing it. The math will be the same, but we have to actually explain what we're doing. It's like kind of being a lawyer. You can't just say someone's guilty. You have to provide logic to explain why. So we're going to do that here. Now we have a weird one. For the first step, we always just say, well, it's given. That's the problem that's given to us. We just use it. So now I look at, well, what do I need to do next? Well, I need to add 7 to both sides of the equation. So I would know then that 3x is equal to 21. Now, how did I know to add 7, or why can I do that? Because the addition property of equality tells us that by adding the same number to each side, the equation stays true, or stays equivalent. All right, and then the last thing we do on this particular problem is divide both sides of the equation by 3. So then we would know that x is equal to 7, and we got there by the division property of equality. All right, our last one. Let's take a look at number 8. Again, we know the original problem is the one that's given to us, so we can just write given. And now our job is to get x by itself. And when I look at this, the first thing I'm seeing is I need to move that 4. So we're going to subtract 4 from each side. So 7 is equal to x over 5. What allows us to subtract the same thing from both sides of an equation? That's the subtraction property of equality. I bet you can guess what's coming up next. We still need to get x by itself. So we'll go ahead and multiply both sides of this equation by 5. So we would know then that 35 is equal to x. And again, we have to ask ourselves, what allows us to do that? What tells me I can multiply both sides of an equation by the same number? In this case, it's 5. Well, the property is called the multiplication property of equality. All right, folks, I hope this video is helping you to understand what's going on here. Feel free to back up and rewatch any segments that you're a little unsure of. But the key is come to class next session, ready to roll, and we'll get you an assignment and we'll go from there. Have a good day.